My name is Nicolas. Probably more people know me on my handle Ruflin. I'm working for Elastic. I'm an engineer at the Beats team. Actually, thank Paul, wherever you are, to do the intro. I had another meeting, sorry about that. So let's directly jump into it. Who in here knows the Elastic stack? It's like 1/3. So let's spend a bit more on the first step then. So the whole talk is going to be pretty quick, but it's basically about getting the logs that you produce with your self-built application into a central place and actually make sense of it, because otherwise just your logs on the server are not that useful, except if you SSH into the server and use tailf to look at them. So the Elastic Stack is here to help you with that. And if we look at the Elastic Stack, it basically consists of three major. The central part, Elasticsearch, is where all the data is. It's stored in a Lucene index, so you can query it. It's going to index your log files, which normally have text message inside. You can search for whatever you want, you're going to find it. Then we have a UI on top of it, which is called Kibana. So you don't have to use the command line to interact with it. You can build dashboards. And we have the ingestion layer. Somehow you need to get your logs into Elasticsearch. And there is Beats, which you normally install on all your machines you have on the Edge node. And there is Logstash that is actually much more powerful and more a server component, but can do a lot of processing with your logs. We're going to focus on Kibana, Elasticsearch, and Beats today. If you already know the stack and you have Logstash in place, you probably know already most of this. So let's get started. We're going to start with FileB. So basically, FileB is mostly a simple tool. All it does is tailf. So it takes your log file and tails it. So let's assume you have your service, and actually it's going to write logs to your service.log, and these logs get rotated. That's all the configuration you need to define. You define an input. It's a log input here. You're going to define a pattern for your log file, and the output sends data to Elasticsearch. That assumes Elasticsearch is running on the same host. Normally, that's obviously not recommended. So either you send your data to your Elasticsearch cluster, or you have a hosted version like Elastic Cloud. Are actually for logs, and I always recommend using log files because the file system, operating system are actually pretty good in dealing with files in general, because that's their foundation. So you have already queue built in. But if you prefer TCP or UDP to make sure you use some log lines, or syslog, you covered. The inputs on the right side are still in beta, but you can use them and they work. They're going to be GA pretty soon. So basically what you do is FileB is going to open a port. So if your service already supports syslog, you can just send your logs there and have the same effect. So what we're going to do now, you have to set up Elasticsearch or just use a hosted Elastic Cloud version. We have a hosted Elastic Cloud. Start your application. That part you're going to know best how to do it. Run FileB with the configuration we had above, and we're done. So I think Martin would be pretty angry if that was my talk. But what you got now is actually all your log files in the format per line. You had it in the file in the central. So instead of having to go to each of your servers to figure out what goes wrong in the log files, you have them in Elasticsearch, and you can search for them in a central place. So you don't have to SSH into servers. So I think we already made a big step forward. But wait, there's more. So raw log lines are often created for humans to read. And that was the case 20 years ago. It's still the case today. It's a bit changing, but still, how often did you actually read a log file? Is anyone in here that never read a log line? Good. So you're still doing it, and you're probably going to keep doing it for the next 20 years. Sorry about that. But so what we're going to do now is at least understand a bit more about the log line. Two things which are normally pretty important is the timestamp. When something happens, so in case you have an incident, you can search for the specific time frame, and the other part is the log level. We call it log level, you can call it severity, but you're probably all aware of warn, debug, error, info, and all these things. So what we're going to assume now, we have a log message that looks like this. Pretty simple. So on the FileB side is a so-called dissect processor. We're going to define the first part in square brackets, it's a timestamp, then a space, log level, message. What that's going to do is split up your event in 3 parts, a timestamp field, a log level field, and a message field. The message field, obviously, by Elasticsearch is still going to index, so you'll be able to search for log, going to be able to search for my, or you can even combine search for my and message and still get results. And that's what it's going to do. Ask another way around, who has, for example, runs Apache or Nginx. So that works and is actually very efficient. So you get already structured logs into Elasticsearch. Unfortunately, there are more complicated messages, and that example from an Apache error message. In your search, you actually normally define how the log looks like or the library you use. But you have an IP address in there, you have a time in there, and their grok comes to the registry. Anyone heard of grok? No, not many? Okay, so grok is basically a definition on top of regexp that expression. So instead of having to write the definition of a timestamp or an IP address, it has it already defined. So there are 2 ways to process log Elasticsearch. Either you do it on the edge, or you do it in Elasticsearch. You can put logstash in the middle, and you're going to be able to do much more complex processing and lookups, but we focus on the simple case. So on the edge node, we support this dissect, which is basically also regex, but very simple and efficient. And grok can become very complex. So we want to make sure that the FileB detailing is very efficient, gets your log files quickly off the edge node, and on the central part we can do the more heavy processing. So what we do here is it's JSON format, but basically you find the pattern here, and grok expression for Apache timestamp, and we say it's IP or host because we don't know if Nginx or Apache in that case log. I mean the host or do an IP address. So doing that yourself in grok. Even define these. We get out in the end is also a processed structured JSON document. It's going to contain the timestamp, it's going to contain the log level, it's going to contain the address, and so on. So if your application produces complex log using a processor that is running when you send your data against Elasticsearch, it's running before the data is ingested there. There is also a failure we can define, like let's assume we defined that's the way your log message looks like, but it isn't. You're going to get at least a failure, and the message is going to be written here. There are the 2 ways to process your unstructured log, I will call it. Some people have JSON logs, which is nice, and a lot of people think it's the savior and it's going to solve all logging issues. It's not. I get to that later. But so basically, JSON logs, and you already put your own structure inside. All you have to do is define a decode JSON processor. With the field, you need to define the field which it's going to be in, which is by default message field. It's going to take your JSON, decode it, put it into a JSON event in Elasticsearch, and you're going to be directly able to search on the fields. Who in here runs Docker? Do we need fun with logging? So Docker, let's say logging is interesting around Docker. And we do our best to integrate with Docker. There is still chance that you can use log lines, which is just related to the way containers work and how short-lived they are. But the way we currently do it we have a so-called Docker input, is we actually read from the files that Docker can write, because then we know it's persistent. So if you want to get all your logs from all your containers, that's all you have to define. You're going to have to mount into the sidecar container the Docker socket, so we actually know which containers are going to show up. But basically, we get all of information coming from Docker on which containers are running or not. And based on that, we spin up so-called event to get these files, add some meta information about the event. Because assuming you just have before, you have all lines from 100 containers, but you don't know which container, it's pretty useless. So what we do, we're going to attach the container ID, we're going to attach the container image, so you can then filter, for example, for your Apache containers, and you get all the information. So are we done now? So the only thing you have to do now is install Kibana, or just use Elastic Cloud, so it's installed, and then add your visualizations for the log. So my expectation is that's the way it's going to look like. So if you have IP addresses, you have cheap IP information, you can, for example, have maps in Kibana, you can do caches on the right side based on countries, how many requests. That is actually, I'm not sure, I think it's an Apache visualization for Apache logs. But that's what you can do in the end to feed your own service best. So now that we get all the data, we get set up. How many minutes do we have left? As long as you give me 5 minutes more. So I spent probably about 2 years figuring out how TLF works. It doesn't work the way you think it should. So I always worry about job security. I want to give you some advices on what you should do to make sure you keep me busy. So first thing you should do, use log truncate. Because in that case, for sure you're going to lose log lines. You're not going to be aware of it. And you're going to realize that with log truncate, as a log rotating mechanism, you have lost log lines, you're going to complain to the log tailing solution. So that's good. Always use log truncate. It's going to mess up. Next one, multi-lines, stack traces. Java stack traces are a good example. You have a timestamp and below everything is indented. But if you want to make it really funny, write multi-line, that's very unpredictable. So if you as a person struggle to figure out which lines belong together, I can guarantee you the machine is going to struggle too. So make sure always to have unpredictable multi-lines. Then JSON logs. If you use JSON logs, don't be satisfied with just 3 or 4 fields. Like if you have a big team of 100 engineers or already 20, make sure every single person uses their own fields. So when you want to query it, you have no clue what is inside, and you're going to cause issues also on Elasticsearch because you're going to have a field explosion. That's actually a lot of fun, and I see that more and more often with JSON logs. Thousands of fields and nobody knows how to query it, even though JSON should solve all of it because it's structured. So if you have 4 or 5 fields in JSON, you're probably in a good spot. Then, who doesn't love to write logging frameworks or your own library? All of us did it. So make sure to not use it, because these people actually had time to think about how logging works. So reinvent it yourself. And here comes the next advice, like stop using new lines at the end of a log file. Because if you don't use it, it's going to be impossible to define if actually that's the end of your log line, or is actually your application still writing. So the best way to implement that is just that every new line you write actually has a new line before at the start. So that's going to mess up everything. So no new lines anymore. That's so old school. Another thing to mess up things is instead of installing beads on all the edge servers, be smart and install it on the central server. In the best case, use rsync. Because rsync, what it's going to do, it's not just going to append your file, it's actually going to write logs. So the log tailing solution is going to get very confused. It's not going to know where it is in the field because there's just a file showing up with blocks and it's not written like a log line. So you get a lot of cases with that, which is a lot of fun. Just to say, I saw all these cases in the last 2 years and they're to go on.
No way.
So then Docker. Docker just appeared on the stage and just caused so many fun things. So if you have log lines, make sure you have log lines which are bigger than 16 kilobytes. There's a hard-coded limit of 16 kilobytes in the Docker logging framework, and it's not going to disappear. So they have a multi-line feature, and I think we figured it out by now. But if you want to mess with everyone, just write all the log files, log events bigger than 16 kilobytes, and see what happens. And then Docker containers have normally two outputs, standard out and standard error. So if you want to make it really tricky, make sure you run multiple services inside, or you have different logs published by your service, and they have completely different log structures. So if you try to process a log from a container, all is going to be messed up. Same for Kubernetes. I'm now going to run through because probably Martin's going to tell me I have 30 seconds left. 5 minutes left? Oh, man.
Now I can tell you 5 minutes.
Okay. So please consider all the recommendations I made before to just make our life miserable for a log tailing solution. So there's more. You're going to write your own application, and it's going to create logs. But I see most of your application, except you wrote your own database, your own web server, you're going to have some like Nginx, Postgres, MySQL. So the nice part about FileB is actually we have modules for that. So we wrote the grok patterns. We wrote all the ingest pipeline. So you can just run FileB modules, enable MySQL, and it's going to tell all your MySQL structure for you. So if you have a service on that list, you're covered. We're constantly adding new ones. And for Docker and Kubernetes, we actually also tail the logs from Docker and Kubernetes itself. They also have logs. The nice part, you also get nice dashboards out of the box. So here we have actually one from Audit, which I didn't present, but in basically every module you're going to use, you have already the dashboard loaded. So you see what's happening in Apache or MySQL. Then that is actually not released yet, but something that's coming pretty soon. We realized searching not necessarily what all people do. Quite often, people still go on a server and want to tail logs and see just more what happens. So what we're doing is basically building tailf into Kibana. So instead of just getting one log files, you have now all the Apache log files. You can filter on it in real time, the search on the top. So you just get error logs or you just get the info logs, but you get this tailf experience that a lot of us and especially sysadmins are used to. Logs are nice, but it's only fun when they wake you up at midnight. So we have an alerting feature in the stack, and you can configure it to a threshold, or if you get a critical message or a search is met, you get an email, you get a PagerDuty message, whatever tool you use. And what would be a talk without mentioning machine learning? Probably should say AI, but it's not. So it's machine learning. We have a machine learning feature that kind of predicts the way things should be. And until recently, we kind of notified you when something happened that didn't look like in the range of things that should happen, which is already very powerful. The other things we recently added is also that it can make predictions. So just a very simple example is, when are you going to run out of disk space? It can predict it for you. So perhaps you probably should fix disk space now because in 3 days you're going to run out of it. It's a very simple example, but you see the machine learning algorithm can actually deal with most data which has actually timestamps. So it's for time series data. And the last thing, which is still in beta, we actually have a special blog about it, which is Canvas. Canvas is basically a presentation tool. Like all of you have probably used PowerPoint or Google Presentation. The beauty of it is integrated with Elasticsearch. So you're not going to create a static presentation. It's all the, I actually don't have a GIF unfortunately. All the data you see in here is changing in real time. So if new data comes in, it's like it's the dashboard, but you can make it beautiful. So that's actually it from my side. I hope I gave you a very quick overview how you can use the Elasticsearch for your logs to store them, to scale up. You can have, we have solutions 100 gigabytes a day, a terabyte a day, terabytes a day. You can scale Elasticsearch pretty broad and you're going to be fine. So.